Today we are going to be talking about arithmetic sequences. By the end of this video, you should be able to describe an arithmetic pattern, you should be able to find the nth term of an arithmetic sequence, and you should be able to find the sum of an arithmetic series. First, an arithmetic sequence is one in which each term is found by adding a constant. We use the letter D for common difference to the previous term. So this means we are adding the same number every time to get the next term in the sequence. So if we start with the sequence 32, 38, 44, each time we are adding 6. So that's the pattern we're going to continue. Part A says, find A sub 1. That means we are looking for the first term, which is just 32. Part B says find A sub 6, so find the sixth term in the sequence. One way to do that is by continuing the pattern. So if we continue to add 6, we get 50, 56, 62. So the sixth term is 62. Part C asks us to find A sub n, so we are looking for the rule for this sequence. We know that we are adding 6 each time, so our common difference is going to be 6. Arithmetic sequences operate much like linear functions, with the common difference being like the slope. So we are going to have 6 times n, because we are adding 6 each time. If we need the first term to be 32, then that means when n is 1, we end up with 32. So 6 times 1 is 6. We would need to add 26 to make sure that our first term is 32. And you can continue plugging in numbers for n to verify that we get the same numbers in this sequence written here. Then we want to find the 712th term. Obviously we don't want to write out 712 terms, which is why this rule is helpful. So we just plug 712 in for n. And we get that the 712th term is going to be 4,298. One formula that may help in general is this. For any arithmetic sequence, A sub n is going to equal A sub 1, or the first term, plus D times n minus 1. So if we go back and look at part C, we know that our first term is 32. We know that our difference is 6. We could have written our rule for the nth term this way. If you distribute and combine like terms, you end up with 6n plus 26, which is what we had originally. Now, if we have an arithmetic sequence and we know that the fourth term is 11 and the 13th term is 65, we want to write the rule for this sequence. So I'm going to start out by writing out some blanks. We have the first 3 terms. We know the fourth term is 11, 5, 6, 7, 8, 9, 10, 11, 12. We do not know. And we know the 13th term is 65. We need to find 2 pieces of information, the difference and the first term. Let's start with the difference. Whatever that happens to be, we know that we are adding D each time to get to the next term. So, to get from the fourth term to the 13th term, you're going to add the common difference, 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So if I start at 11 and I add D 9 times, I should end up with 65. We can solve this and figure out what D is. We subtract 11 from both sides and divide by 9. We get that D is 6. Another way we could have figured out what the common difference is, as I mentioned before, arithmetic sequences function a lot like linear equations, with D being similar to the slope. So if we think about the slope formula, with the terms being the y and n being the x values, we could have 65 minus 11 over 13 minus 4. And that will also give us 6. Again, there are two ways to figure out the first term. Since we know that you add 6 to get to the next term, we could subtract 6 and figure out what the previous terms are. Subtract 6, subtract 6, and find that the first term is negative 7. If you prefer a more algebraic way, if you use this formula, and I'm just going to pick 11 being the fourth term as the piece of information I'm going to use. I know that 11 is the fourth term. I don't know what the first term is. I found out that the difference is 6, and 11 is the fourth term. I can then solve this. And get that the first term is negative 7. Whichever way you prefer is fine. Once we have the difference in the first term, we can write the rule for the nth term. Next, I want you to find the sum of the first 1,000 positive integers. So yes, you could take a calculator and start adding 1 plus 2 plus 3 plus 4 and continue all the way to 1,000 and see what you get. But that's going to take a while, and there's a pretty good chance that you'll make a small mistake somewhere. So let's think about this the way that Gauss thought about this. We are trying to add all of these numbers. If we look at the first number plus the last number, that gives us 1001. If we look at the second number plus the next to last number, 2 plus 999 is 1001. 3 plus 998 is also 1001. 4 plus 997 is also 1001. So we will end up with a bunch of pairs that add up to 1001. How many pairs will we have? We'll have 500 pairs. So we can just do 500 times 1001, which gives us 500,500. But we do have a formula that can help us figure this out as well. This says the sum of n terms is n over 2 times the first term plus the nth term. This is essentially what we just did. If you take the first term and the last term add them together, you will have n over 2 pairs that have that same sum. So let's look at one word problem here. There are 20 rows of seats in a theater. There are 25 seats in row 1, 26 in row 2, 27 in row 3, etc. What is the total number of seats in the theater? And if tickets cost $7.50, how much for a full house? So, we know that there are 20 rows. That means that n is 20. We know that the first row has 25 seats. And we can tell that the difference is 1, because each row has one more seat than the row in front of it. So if we try to use this sum formula, the sum of the first 20 terms is 20 over 2 times 25 plus, we don't know how many seats are in the 20th row. However, we can figure this out. If we need to know the 20th term, we can just go back to the formula we used earlier. The first term plus the common difference times n minus 1. And if you do this calculation, you end up with 44. So then when we go back to the sum formula, we have 10 times 69, so we have a total of 690 seats. To answer the second question, if tickets cost $7.50, we multiply 690 times $7.50, and we get $5,175 for a full house.